provide us with the option of getting real-time data to an LLM. We can integrate multiple APIs into a single LLM. Then we can obviously the user in the front end can get the real-time data and also get insights on that data from the LLM itself if the LLM is trained to do some certain sort of work. So yeah, that will create a difference. This is the three different prompts and the responses of these prompts. So one of them is one prompt which I have given is check if the string is a palindrome. So yeah, ABBA is a palindrome and the response that it returns is true. Then if you go to arithmetic prompt, then at 45 and 67 it will give a valid 112 response. And for news as well, if I just give a prompt, tell me the top headline.
So what is this API for everything? So basically, whenever you build a website or build an application, the first and foremost thing is that you have to have a connection between the front end and back end, and that is provided by the API. So the back end contains all of our business logic, and the front end connects to the API via these endpoints. The problem is that whenever the user interacts onto the application, the endpoint depends upon how the user interacts. So the user has to interact a certain way before the front end hits that endpoint. So this is something which is hard coded, because it's always going to be that the user will fill a certain form, and the user will click on certain button or click on some certain element, and the certain API will hit. So this is something where the user has to interact a lot with the front end. So this is something that I just feel is inconvenient for a user. So what we can do is we can just simply let's say chat gpt. So chat gpt is something which is very convenient and a very nice option for us, because we don't want to go on to Google search and then search for something and then click on some link and then find out and then read out everything that is over there. So whatever information we want, chat gpt gives us then and there itself. So what enables the chat gpt is the LLM that they have built upon. So we will be also using an LLM, but the problem is that these LLMs are not real time. They don't have data of the current situation, and they don't have data of even of, let's say, past 2 months or 3 months or anything of that sort. So we just don't want that. We want the LLM and these API, real-time APIs of different kinds, to work together, so that we can get real-time data along with LLM, and the user can actually put any prompt in it, and the user can actually get any data with just us by just writing a simple prompt. So it's not going to be a very heavy application, but we'll just try to explore this kind of an approach, and let's see how it goes. So I'll just explain the architecture of how we will be doing that. So firstly, let's say we have okay, so this is our, let's say, front end, or yeah, so this is our front end, and we have uh, we have different APIs that are used to get data from, to send data to the front end, that is to the client. So let's say we have an API one, or similarly we have an API 2, then you have an API 3. So let's say there are these APIs and there are many of them. So what we are trying to do is, from the same prompt, a user can get access to news, user can get access to finance, user can get access to, let's say, anything, let's say sports data. The user can get access to any real-time data that fluctuates every day. So that is something that we want to do. So there are different APIs. Let's say you have some news API, then you have some API that gets the finance data, latest financial data. Then you have some API that gets you the latest sports news or latest sports scores or anything that is going on with sports. So there are these different APIs that the front end will be interacting with from a single unit. We don't want any different any different interactions or any different buttons on the front end that the user will interact, and then it will hit on to the API. So that is something that we just want to remove. The user will just put prompt, and this prompt will straight away hit on to this API. So we need to develop something in this space that will identify which API to hit to, and will hit the API as well and get the response according to what the user wants. So for that, what we can do basically is, obviously whatever application we'll be building, will have our own API as well. So this API will enable us to, let's say, it will enable us to connect to the LLM. So okay, so let's see where the LLM sits in this architecture. So if you look at this, the first thing, whenever the user is going to send a prompt in the form of text, so we need to understand that text, parse that text, and then go and send the request to a certain API, whichever we want to. So in a large use case, what we can do is, these APIs will be stored in a database. So in this, let's say we have a database as well. So this is our database that consists of all of these APIs. Okay, so I'll just, okay, so the database consists of all of these APIs, and let's do this. Okay, so this is our database that consists of all the data of all these APIs. So it will contain an the API endpoint, it will contain all the request parameters that this API takes, and many different things like, and along with that, it will also be having the function of what this API does. So according to this, we will be identifying which API we have to hit to. So all of this will be present in the database. Now the first thing that will be done is, whenever we will have an API that will, this is our own API, the API of the application that we are building, and these are, let's say, third-party APIs or anything of that sort. So what we'll do is, whenever the user sends a response, so whenever a user sends a request that consists of a prompt, so firstly we will have to uh, have something that will understand that prompt and get the type of function that we want from an API. So okay, so I'll just write these steps over here. So the first step would be to understand the user prompt, and uh, identify the, let's say, first we will have to identify the topic with which the prompt is dealing with. Let's say if it's news, then we'll have to deal only with the news API, because we don't want a lot of things to be coming from the DB. We cannot, there will be thousands of APIs in a larger scalable scenario. If we talk about a scalable scenario, there will be thousands of APIs that will be put onto the database, and we don't just want all of these 1,000 APIs to come onto our server and then we identify which of them to use. So we just want a very small amount of them. So basically what we will be doing is, we will assign a topic to these API endpoints in the database. So let's say if it's about news, then the topic would be news. Let's not topic, or maybe category, or whatever field that we'll be putting up. So it will be news or finance or sports or arithmetic operations or anything. So first what we will have to do is understand the user prompt and identify the of category of a category it belongs to. Okay, so this is the first step that we'll be doing. The next step that the API will do is, now once we get the topic, get all API endpoints along with their functions, along with their function descriptions. So function descriptions would be the description of the API. I mean, whatever the API does, that will be described in the database. So get all API endpoints along with the function descriptions from the database. So let's say in the first step, our API identifies that it's a news thing, something the user wants to have something about news. So if the category it belongs to is identified as news, the next step that we can do is get all API endpoints that are related to news. Now once we get all the API endpoints related to news, we will send the prompt, the user prompt again, user prompt and an array of API endpoints back to the LLM again, and the LLM will now identify which API endpoint will suit the user prompt that has been obtained. So this is our step 3. So in the step 3, what we'll be doing is first we need to convert. Okay, so we will send the API endpoints array as well as the user prompt to the as well as the user prompt to the LLM. Now the LLM will identify which which API to hit, and also get the get the get the request parameters from the user prompt itself. So we'll have to identify the request parameters from the user prompt. So let's say if it's news, sometimes it will be a case that we need to have a date, the date, time, and the country that somebody is living in. So all of these things are also required. Maybe we can use some geolocation API in the front end that will enable us to fetch the latitude, longitude, and then we can fetch the location of that certain latitude, longitude. But currently we'll not go into that complexity. Uh, we'll simply add everything in the prompt. So let's say if we want news from India, so it will be like we'll be giving a prompt like give me some top headlines of this date in India. So and the API will figure out what is the country as we will have to send country as a request parameter. Then the API itself will identify the date is also given in the user prompt. So we'll be working in that way currently. But if in case there is no date, time, and place not mentioned by the user, in that case we'll have to use some geolocation API or something that will identify all of these things. So that can also be done, but currently we will not get into that complexity as of now. So LLM will identify which API to hit and also get the request parameters. Then will construct the API endpoint string and use fetch API or Axios to hit onto it. Once the response is obtained, send the response object to the LLM ask for uh, ask for it to convert it into a readable human format, and this send the response back to the user, that is the front end. Fine. So this is what we will be doing, and these are the steps that we have to implement in our API so that we can do all of these things. So basically, firstly, let's build this thing because we won't be using any third-party API. So there will be some API endpoints that I'll be making up myself. The very basic API endpoints like calculation, multiplication, addition, any arithmetic calculations of that sort. And let's also add something related, and let's try to add APIs of different kinds. So news, finance, and this thing, the calculations. So these are the three things that I've thought of. For news, I'll be using the news API and the API key that the news API will be providing. So for that, I'll create another API. The For news, I will be creating another API that will interact with the news API, because I don't want to disclose the API key. And apart from that, for calculations as well as for the for any other, let's say, finance related stuff, I don't have any finance API as of now. But okay, so let's keep two APIs: news API and the calculations API. So let's try building something over this. If the LLM works fine, it's good. So, and also so in this API we will also be having an LLM that will interact with everything that we want to. Okay, so this is how the things are going to be. So let's see how it goes. Let's start building this. So first we'll have to build the backend itself, all the API endpoints, and then we'll work with the front end, and how our API, how will the LLM identify and hit on to the perfect API. So let's start here. Firstly, I'll be creating a directory. Let's say. Okay, so basically what I want to do now is that I'll just create an API, a very simple API, which will contain different functions, and we can then hit onto that API, and then we can let's see how the LLM works with it. I'll be creating very simple APIs. One will be for operations. Maybe I'll just write it down somewhere. So one will be for operations, arithmetic operations. So one will be the arithmetic operations. Another will be for let's say anything string manipulation, maybe something like you want to remove spaces from a string or anything of that sort, a very simple function. Then you will have an API to fetch news. So for that I'll be using news API. And okay, so these are the three APIs that we'll be working with initially. In string manipulation we'll be having very simple functions, and okay, so this is how we'll be working. These will be the three different APIs, and our aim is for the LLM to identify which API or which topic it has to hit to. Now the thing is that whenever we create a news API, there will be whenever we deal with any third-party API, we'll have a API key that we will be using. So for that, what we can do is we will also have something like, okay, so what we have done is get all API endpoints along with their functionality on the database, send the API endpoints array as well as the user prompt to LLM, along with the API keys in along with the API keys that are API keys in the environment variables. So in generally the API keys that we use are stored as environment variables. So whenever we whenever we send the API endpoints array and the user prompt to the LLM, along with that we also send the API key and ask the LLM to identify which API it has to hit to. Along with that, also use the API key that you want to use. That's it. So this is something that we are going to do, and we also don't want any we also don't want the LLM to hit onto some API which is not available. I mean, if it does not have an API in the database, then it should not be sending any data, any latest data to the front end. So I guess that can be taken care of anyways. So what we basically have to figure out, the first and foremost is to uh, we set the LLM up and set this API up to hit onto the accurate API on this side. So let's do something. Let's first create the backend API. So I'll just create a new directory, which I'll point to it, and I'll start coding here. Okay, so now we are ready with the backend API. Now let's try to build the LLM API, and then we'll test it with the Postman itself. So I'll just create a new directory. Okay, fine. So okay, so the LLM API is also created. Let's just set this up. Okay, I'll just install the Express. Now I guess it will start. Yeah, it's working. Let's define the service here itself. So what we'll be going to do is we'll have a request and response. Firstly, we'll have to get the request prompt. So const prompt equals request dot body dot prompt. Yeah, that is fine. Now we will have to connect to the LLM. So there are different ways in which you can start the LLM in your system. So One of them is you can have this thing called as llama.cpp. So llama cpp is an interface, or let's say a service that will run an LLM into your machine. So these are all different LLMs that can run on it. Moreover, it has bindings with different languages. So if you select Node.js, then you will get the entire documentation of how can you interact with this LLM and how can you get responses to your prompts and everything. So this is llama.cpp. uh, but for some reason it wasn't working in my system, and for llama.cpp we need to find these gguf files that we can find from Hugging Face or something. So these are the gguf files that can work with llama.cpp, and then you can run this model into your system. But currently I'm not using that. I'll be using a simpler interface, and that is Olama. So Olama is a little bit of a simpler interface. It works like Docker. So whenever you can pull some models onto your system, you can run those models and then you can work with those models. So along with that, it also provides you an API. It also starts a web server on a certain port, and with that you can also connect to the API, connect through the API to these models. So this is what we are going to use. It's Why are we not using llama.cpp? The only reason is that it's simple to set up. Olama is simple to set up, and you also get an API through which you can interact very easily. So what I'll be doing is I'll be using Llama 2 because it will work with it will work well in my system. Otherwise, for the models of larger parameters, you need to have better systems and you need to have better RAM and stuff. But the 7 billion model will work in my system, so I'll be using Llama 2. And along with that, okay, so here with Olama, the thing is, we can define a model file in which we can instruct the model to, I mean, we can fine tune the model to a bit of an extent. So what we can do is we can just build this model file. We can create a model file. In this model file there are many different things that you can add. The parameters, so temperature. So the temperature is about how creative the model is going to work, and this is the system prompt. So in a system prompt you just fine tune this entire model by telling it that you are XYZ and your task is to do this and this. So this will create the model. This will create a better tuned model for us. And these model files can be very complex, but we will currently just add the system prompt to it, and then start running it. So to use the model file we need a model file, then create this model, and then we can start running this model. So whenever we create this model, it will pull llama, it will pull whatever model we have added over here. It's just like Docker. So it will pull this from the Olama registry or Olama repository, whatever you call it. And from this, once it is pulled, it will also configure this system prompt to it, and then we can start using this model. So let's see how do we do that. So I'll just, okay, so let's create a model file. I'll create a model file saying llama 2, okay, llama API LLM. Let's give it a simple name, LLM API. Oh, LLM. Okay, so just give it a simple name, API LLM dot model file. Or else we can also create a model file straight away, and we will just add some things to it. I'll take the latest one. Then apart from this, anything that you want to set up would be a parameter. I think we don't need it now as such. Okay, so yeah, so these are different parameters that you can set: seed, stop, and there are different things, and you can read this description, so you'll get to know how all of this is working. So I'll just add parameter to be parameter temperature to be 1, and then let's add the system prompt that would be you are an API finder. Your job is to find the correct API endpoint to the user prompt that will be provided to you. So that's it. So this is it. I guess that would do it for us. And we'll create this model. So for that we will use a command over here. Okay, Llama create LLM API model. LLM API and the location of the file. So let's this itself Llama create file. So it works simply like Docker. It will now pull the model and then add the system prompt to it, and our model will be ready for us to use. So while using it, we can just start the model and start using it. Also, we have an API for this that we will be using continuously. So we can uh, interact with this model by this API. It starts the model at 11434 port number, and we can just simply give the model name and the prompt as a post request to this API, and we will get the response. So the response can be any of the response can be in the form of string, in the form of stream. The stream that you get would be uh, would consist of this entire JSON object. So what we will be doing is we don't have to interact with we don't have to send this data directly onto the front end. So we are not concerned about this. So we will just set this stream as false, and when we set the stream as false, we'll get to have the entire string as and when required. So yeah, so we will not be worrying about stream. Yeah, so I guess this is how the response will be obtained. mm, okay, so that's it. Let's see how it goes. Let's wait for the model to be pulled up. Okay, so the building of the model is done. Now if you just see Llama list, then you will have Llama API that has been built up. Now what we can do is we will just try running this Llama API. LLM API. Let's see how it goes. So it will take time to run, and also it will take time to respond as well, because we don't have such high computation available. But I guess that's enough for now. So let's write who are you. Yeah, so this is what we wanted. This the system that we have given will stay throughout the model, and whenever the model is now fine tuned to get us the correct API endpoint for our needs. So, and that is what it is telling us, that this is the identity of that AI. So this is something that we can fine tune, and in system model we can add many other things. but currently let's keep it this much, and let's proceed. So now okay, so we have started our model. What we can do is we'll try building we'll try hitting onto this model something. Let's take a request, and LLM API test. Okay, so let's try sending this request to the model. Okay, so as you can see, we received the stream of responses. Yeah, and the response, as you can see. Okay, so cut let's just get out of and add another thing to it, that is stream. So we'll set stream as false. Let's see how it goes. It should now just return only the response as a whole, and it should not return this stream that we had obtained. So let's see how it goes. Okay, so this is the response that we have received, and as you can see, to find the correct API by the sky blue, I would suggest using a search engine or an API that provides information, and so on and so on. So this is something that we wanted to do. Now the difference is that whenever we write a prompt, the prompt will be sent from the API that we are creating, and the prompt that we will be sending would have the user prompt. As along with that, we will also send the list of APIs from which the LLM will have to identify which API is suitable, and we want the API to return that as a one word answer. We don't want anything else in the response, because it also takes time. Along with that, it's not needed as well. So we so basically our aim now is to send the prompt in a proper way to this API, and receive the response as we want it to be. Okay, so let's try doing this. So let's say we have a prompt, and the prompt is received from the body. Now what we'll have to do is we'll have to first get the topic. So three different topics that we have is the news, then you have another is, what do we have? We have news, arithmetic operations, and string manipulation. So arithmetic operations and string manipulation. So these are the three topics that we have, and the first thing is we have to identify which topic it belongs to. So what we had discussed in our system design is that we will have a database that will consist of all these things. Currently, for now, considering that the LLM is taking up a lot of resources of this system, I will not engage with the database now. I will just create an array that consists of different APIs, the topics, and all the information that we want to have in it, so that we can proceed further as and when required. So let's declare that array here itself. We will call it as, mm, let's say we'll call it as API data. We have an array of objects. So firstly I have, let's say, API endpoint, then we will have, okay, so we'll fill this up and fill this up later on. Okay, so let's fill it up now itself. Okay, so we have added the entire API data in this array. The array is populated. So currently I'm not using a database because already there's an LLM which is running and it takes up a lot of space, as well as it takes up a lot of resources, because of which I'm not willing to start the database as well here. So that's it. API, we can just get this API data here. Yeah, so we can import the API data. Now the first thing is get the topic, which topic it belongs to. So the topics that the API is going to serve are going to be static, obviously, because there are limited number of topics for which we are going to deal. So these topics are going to be static, so that we can declare. We will declare an array which will be news. Then you have arithmetic, and along with that we also have string. So these topics are in line with the data that we have. So we have three different topics: topic as news, arithmetic, and string. So these are the three different topics that we have. If we add any other topic, we can add it to this list, and this array or this list is going to be static anyway, so it doesn't matter. So we have these topics now. Now the first thing is we just have to determine which topic the API belongs to, which of these topics. So this is the step one of our process. So first we will determine which topic it belongs to. Okay, fine. So the prompt that we have received from the user is something that we have, and now we can hit onto the API. Let's keep it as async. I will also introduce Axios here. Okay, so Axios is not installed, so I'll just okay. So let's see. Const response is equal to Axios dot post onto. First we'll create a request body. I'll add the LLM name model. Okay, so I'll add the model name to LLM API latest. So this is my model name. Along with that, I also have to send the prompt. So yeah, that would be fine. I'll just hit on to this. Okay, so this is the endpoint that we have to go for. We need to generate the response for this API slash generate, and then you create a request body which consists of model as model name, along with that the prompt. So what will the prompt be? For that we will first given is the user prompt, find the topic. Given is the user prompt and an array of topics. Return in one word which topic the prompt belongs to. The user prompt belongs to response. Send the response in one word which topic the user belongs to, and given is the user prompt, so this would be the prompt, right? So this is how we will try getting the response. Now what I'll do is just response dot data. I'll just log it out here. Let's see if it works. So host 8081/LLM. It's a post, I guess it's a post request. No, it's a get request. It's the body. Let's keep it as post. That would be better. I'll send a post request. Along with this, the most important thing is that stream has to be set to false. That's fine. And /LLM, I'll send the body and in the form of JSON. So this is not working for some reason. Okay, so we just have to add this thing app.use express.json. So what it does is it's a middleware. So whenever a request comes in, this middleware will convert the request into pass the request as a JSON format. So it will pass the request body as a JSON format, and then we can easily use it. So let's see what it does. Okay, it's sending request, which means that it's working kind of. Okay, so there was a problem, I guess, because we had not added this await thing, and the response that we got is undefined because this promise was not resolved and the response.data has been printed already. So what we'll do is we'll do this, and I'll also add this thing over here. Send message as success. Currently we'll just send this for now. Let's wrap it up in a try catch. Yes, so this is fine. So yeah, this looks fine. Let's see, let's try hitting it again. Okay, so here we can find that the response is the topic that it has sent is news. So yeah, this is great. This is fine. I'll have to add something in the prompt so that I can get this topic straight away. Okay, so I'll just declare this outside response because we'll be using the same response variable again and again. So response is get the response, and I need send the response in one word only in uppercase. Okay, so in one word only. Let's not make it complex. Okay, so let's see response.data.response. This is something that we want to look at. Let's do this again. Yeah, so yeah, it shows news now. This is fine. This one is fine. And I would like to just um, okay, So I would like to just remove this new line tag which is coming up over here. The topic is now obtained. Now the next step that we are going to do is get all API endpoints along with their function descriptions from the database. So currently we don't have a database, so we have the API data array. In API data array, we want to return from the API data array all of those objects that are related to this topic. So let's do that. Okay, so how can we do that is using the filter function that Node.js provides us. So let's say const relevant APIs equals API data dot filter, let's say item, where item dot mm, item dot topic equals news, or not news, it should be topic. Fine. So we have all the relevant APIs as well. Now we'll again the will we are on to this step. So we have all the API endpoints along with their function descriptions. So get all the API endpoints. This is what we have done here. Now the next one is send the API endpoints array as well as user bound to LLM along with the API keys in environment variables. So now send the API endpoints with API keys, and so currently we don't need to send the API key. What we'll send is API endpoint with function descriptions. So this is something that we are going to do now. In case we are not having this API, like if we are directly accessing a third-party API, we'll have to send the API key also, and we can send all the API keys that we have exported, or and that will do for us. So currently we have just this news API, which requires an API key, but that also I have inbuilt, that also I have infused in this API itself. So I don't think it will create a problem. So now currently what we want to do is we just have to identify the API that we have to hit onto, and then hit onto it and get the response. So this is our aim currently. We are not focusing on how we are going to operate all of these things. So first, what we'll do is we'll have to send the prompt. We'll have to send the prompt to the LLM again, and generate model name. Now given is the user prompt and user prompt. Okay, so and an array of topics. Here we have and the relevant API endpoints. Send the response in one word only, which API endpoint should be used. Send the response in a JSON format. Let's ask it the response in a JSON format, because we also need all sorts of query parameters that are required. So send the response in a JSON format. JSON format by JSON format consisting of two fields. One would be consisting of two fields. The fields would be endpoint and query, and an array of query parameters. Fine. So this, let's not keep an array of query parameters and query parameters consisting of let's not keep two fields consisting of fields with consisting of fields, one as endpoint and the and others as query parameters. Send the response in a JSON format consisting of fields, one as API endpoint and others as query parameters. Send the response in a JSON format. Okay, so find the relevant, find the API. Find the API endpoint that should be used for the user prompt, and then send the response in the way that we want to. Let's just, okay, so fine. So this is what we will get. What the next thing that we will do is we will just print this response dot data dot response dot uh, response. Okay, so this is find the API that will be used for the user prompt. Send the response in JSON format only, consisting of fields and stuff. Response. Okay, so let's do this JSON dot parse. I'll just take the response and then prompt is also given. String false. Okay, fine. Let's try doing this. So how are we finding the relevant API endpoints? Okay, so I'll also doing on the relevant API endpoints plus I'll say does this, then you will have the user prompt with the prompt and the relevant API endpoints with the API relevant APIs. So I guess that's it. That should do for us. Let's see how it goes. Okay, so there is some problem with this. I'll just print the topic here. Along with that, I'll also print the relevant APIs, and then we are printing the response. Fine. So let's see how it goes. If it goes fine, it's good. Okay, so the topic, oh, okay, so this will obviously create a problem. Let's do one thing. The problem is that whenever the topic is returned, sometimes it is of the type that it will send in this format, that is topic, then colon, and then news. So I'll have to do something over here. We can send the response in JSON format consisting of only one field, and that field would be, let's say, that field would be topic. and yeah, I feel that's fine. Topic. The given is the use for an array of topics and the response in JSON format consisting of only one field topic. Topic the to which the user prompt belongs. Okay, so now it's saying the topic to be India. So this is failing miserably. Okay, I guess I have not sent the array of topics to it, which I'll have to do. So the user prompt and okay, so let's do this. Firstly, what will to which the user belongs to. Now we'll send a user prompt that would be prompt and the array of topics consisting of the API data. I guess that should look fine. Okay, so okay, it is not API data, it will be topics. Okay, so I guess that should work. Okay, so now it's working fine. Then we will have to change the entire prompt, I guess, because it's not working well here. So yeah, I've changed the prompt a little bit and now it's working fine. So what I've added in the prompt is I first added the instruction that the for the response that will be returned should be in the JSON format itself and do not include any additional text, comments or explanations, and then you give the prompt data. Along with that, here as well I've made some changes that first we have filtered out the relevant APIs and then just get the API endpoints array and query parameters array differently uh, because that would enable us to send all the possible API endpoints easily, and the LLM can easily understand this. So I've also taken some help from ChatGPT to generate the prompt, generate a valid prompt that would make the AI help identify these things. So this is done. Now the next thing that we can do is now we need to hit onto this endpoint along with the query parameters and we need the response. So the next thing that we will be doing is create the entire endpoint. So the final endpoint would be await. Okay, so we are generating the endpoint first. Okay, so mm, okay, so what we can do is we have this data. So first, let's get this into a variable const API endpoint data equals JSON dot parse response. Okay, so we have the API endpoint data. Now we need to construct the entire endpoint. So let's see what form of output we are getting. This is the form of output that I'm getting, and here we will be having an endpoint and the query parameters associated with it. So let's construct the endpoint first and then we'll get to the we'll hit on to the backend. So now construct the endpoint. So how do we do that? Let's take string. Let's say endpoint string, and we can now, the first thing that we do is endpoint string plus equals API endpoint data dot endpoint. Right, so this would create the endpoint for us. Along with that, now the endpoint is set. Now we just need to add the query parameters. So if there's and then we will also, okay, so now we need the query parameters. So for query parameters, what we can do is either we can extract these query parameters first into an array and then input it over here, or else if not that, we can do that simply as well. So let's try it simply first, and then let's see how it goes. So what we'll be doing is we will first get the array const query params equals response equals API endpoint data dot query params. Once we get these query parameters, what we can do is we can just check if, okay, so so let's populate these query parameters with the endpoint. So what we'll do is for const element in const element of query parameters. Okay, so the query parameters are in the form of a hash map. So if it is in the form of a hash map, I will have to traverse the hash map entirely. Let's do one thing. Let's not keep it as a hash map. I'll change it to an array in the form of an array of objects with their values populated by identifying the prompt. Array of objects where each object consists of the query parameter variable name and the and its value with their values populated and so on. So let's see how it works first. So we have these query parameters. Now we can traverse this array for const param of query parameters. Let's say we have the endpoint string, then we will just okay, so what will be we will have to do is to add a question mark here, and also update all of these things. So how are we going to do that is by creating a string that will take up q dot name sorry parent dot name and then equals parent dot value. This will happen only if parent dot value then just do this, and okay, so also add the ampersand along with this at the end of the string. This there will be an extra ampersand, so we will have to remove that as well. Okay, so the case that we might miss out here is that, let's say if we don't have any query parameters, if the endpoint if the endpoint is as it is and all the query parameters are null, so in that case, we are adding a question mark, and when we just remove the last character of this string, that time it will be taken care of. Also, in other cases, if we are updating the endpoint string, uh, this ampersand has to be taken care of at the end, so that will also do. Okay, fine. So this will do. Even if all the parameter values are null, this won't the endpoint string won't get updated, and the last character would be this question mark, which we won't need. And once we just remove the last character here, uh, we will write the let's say we write the logic for removing the last character, and uh, once we remove the last character, if there are no parameters, this question mark will go away, and if there are parameters, this ampersand will go away. So yeah, that will be taken care of anyways. So let's see how the endpoint string looks like. Let's just print this out here. Okay, so my system is crashing because of the fact that I am recording as well as uh, I'm working with this LLM, so it's a bit heavy for my system to to handle this. So that is why I have already made three different prompts and the responses of these prompts. So one prompt which I had given is check if the string is a palindrome. So yeah, ABBA is a palindrome and the response that it returns is true. Then if you go to arithmetic prompt, then add 45 and 67, it will give a valid 112 response. And for news as well, if I just give a prompt, tell me the top headlines. Once I give this prompt, the only fact that it is not working well here is that the query parameters it assigns is on its own. So this is something that we don't want. We want to have our own query parameters. So for that we can obviously change the prompt and improve the prompt so that the query parameters that are being set are correct and to the point as we require. So currently the entire thing is working. What was more important is that the approach that we are trying to build here. The approach is that there is an LLM over an API that we are building. So this LLM will undergo the entire API will undergo these 7 steps, and the LLM can determine onto which API it has to hit. So what it will do for us is that it will provide us with the option of getting real-time data to an LLM. So the LLM basically will only have data up to a certain point, up to a point where it has been trained. So that creates a limitation for LLMs. But if we can do this, we can integrate multiple APIs into a single LLM. Then we can obviously the user in the front end can get the real-time data and also get insights on that data from the LLM itself if the LLM is trained to do some certain sort of work. So yeah, that will create a difference. So this is the approach that this is just an approach to what we can do. And yeah, so that's it from my side. Thank you so much.